Hi everyone, hope you all are good. We are here for grade 10 math. So we're working on chapter 3, that is quadratic relations. We're going to start with the lesson exploring quadratic and exponential graphs. So let's just start with the lesson. Okay, here I am on the lesson exploring quadratics and exponential graph. Okay, here is the summary. Okay, patterns in the table of values for y equals 2k can be determined the meaning of a exponent negative 1 and a exponent 0. The relation y equals x square and y equals 2x have the following characteristics. You can see y equals x square is the graph of the quadratic and y equals 2x is the graph of the exponential graph, right? The graph is symmetric about the y-axis. That is for the quadratic relation, and for the exponential graph the graph is not symmetric. Then the graph has an x-intercept of 0 and y-intercept of 0. So for the exponential graph the graph has no x-intercept and y-intercept of 1. Then the y value decrease on the quadratic graph, the y values decreases and then increase as x increases. So for the exponential graph the y values increase as x increases, and x increases is in the positive direction. As x increases in the positive direction, the y value increase. As x increases in the positive direction, the y value increase much faster than the y value that is for the exponential graph. Got it? If the x increases in positive direction, the y increases much faster than y axis. As x increases in the negative direction, the y value decreases. That is for the quadratic relation. That means for the exponential graph, x increases in the negative direction, the y value decreases towards 0. Got it? Okay, let's just start with the practice questions. Okay, let's just start with question number 1. For part 1, you made a conjecture about the value of powers with exponent 0. You can confirm your conjecture using exponent rules. So basically you have to use the exponent rules here and then you have to make a conjecture. Express 3 over 4 over 3 over 4 as a single power using the division rule of exponent. So you have to apply the division rule of exponent here and you have to write them as a single. So you have 3 over 4 over 3 exponent 4 divided by, you have to write it as a single power. So when you have to apply the division rule of exponent over here, whenever they are dividing, that means you have to with the same base you have to subtract their exponent. So 4 minus 4 is 0. That would be 3 exponent 0. Got it? That's how you represent it, a single exponent. Okay, for the b part, rewrite the numerator and denominator of the expression 3 over 4 by 3 over 4 in factored form. Simplify where possible. What is the value of this expression? Factored form, you can write it as 3 times 3 times 3 times 3, because 3 exponent 4, that means you have to write 3 4 times. Then again for the denominator, it's same. When you, they can cancel out and you are left with 1, right? Okay, the next part is, based on your results from a and b, what you conclude. Okay, from a and b, 3 exponent 0 and equals 1. Got it? That's what we conclude from a and b. Any number that's exponent is 0, that means that equals 1. If you are given with a base and exponent is 0, that means the answer equals 1. Got it? Okay, the next one is, repeat a and c using the exponent 5 over 3 and 5 over 3. Okay, just start with question number 3. Evaluate each power, express your answer in rational form. 2 exponent negative 4. Let's just start with question number 3. 2 exponent negative 4. First of all, let me read the question, what we have to do. Evaluate each power, express your answer in rational form. Okay. So 2 exponent negative 4, first of all, we can make the power positive by writing 2 exponent negative 4 in the denominator of 1 over 2 exponent negative 4. Now you can evaluate 2 exponent negative 4, means you have to do 2 times 2 times 2. That means 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So that would be 1 over 16. Got it? Okay, the next one is B part, 4 exponent negative 1. You can write it as 1 over 4. Then you have F part is 7 exponent negative 2. It would be 1 over 7 exponent 2, and 7 times 7 is 49. So it would be 1 over 49. Okay, let's just start with question number 4. Evaluate each power, express your answer in rational form. So let's just start with question number 4a, negative 2 exponent negative 5. Okay, negative 2 exponent negative 5. Okay, first of all, just make the exponent positive. You can write it as 1 over negative 2 exponent 5. Got right? Now you can evaluate negative 2 exponent 5. That means you have to multiply negative 2 5 times. So 5 is an odd number. That means answer must have a negative sign. If the exponent is negative, that means the answer must have a negative sign. So 2 times 2, when you multiply 2 5 times, it would be negative 1 over 32, right? Okay, let's just do B part, negative 4 exponent negative 2. Just make the exponent positive. Sorry, you don't have bracket over here. Let me just write them down. It looks like this. Okay, first of all, makes the exponent positive, so it would be 1 over 4, 1 over negative 4 square, right? So negative 4 is the sign with 4. Just evaluate 4 square, it would be 16. So it is negative 1 over 16. Okay, let's start with question number 5. Evaluate each power. Express your answer in rational form. So it would be a is 1 over 2 square. Question number 5a. 1 over 2 square. Basically, 1 over 2 is a fraction and the whole exponent is 2. That means 2 is the exponent of numerator and denominator as well. So you have to do 1 times 1 over 2 times 2. 1 over times 1 is 1 and 2 times 2 is 4. So it would be 1 over 4, right? Okay, let's just do C part. 2 over 3 exponent 3. So this 3 is the exponent of numerator and denominator as well. So you can write them like this: 2 exponent 3 over 3 exponent 3. Now you can evaluate the exponents. 2 times 2 is 4 and 4 times 2 is 8. 3 times 3 is 9 and 3 times 9 is 27. So it would be 8 over 27, right? Okay, the next one is D part is 2 over 3 exponent negative 3. Okay, first of all, we can make the exponent positive by reciprocal the fraction. Reciprocal means just interchange the numerator and denominator. That's how the exponent can be positive, right? If you are given with the fraction with a negative exponent, you can make the exponent positive just by reciprocal the fraction. So it would be 3 times 3 is 27, 2 times 2 times 2 is 8, so it would be 27 over 8. Okay, let's just start with question number 6. Determine the value of n that makes each statement true. Okay, hold on. Okay, the first one is 2n equals 1 over 8. Determine the value of n that makes each statement true. 2 exponent n equals 1 over 8. You have to calculate the value of n. Okay, just you can write 8 as 2 times 2 times 2, isn't it? That means it is 1 over 2 n 3. You can write it as 2n equals 2 exponent negative 3. You move 2 with exponent to numerator, so it would be then negative. You can see their bases are equal. That means their exponent are also equal. So it would be n equals negative 3. Right? So when you're working with the exponents, if the bases are same, that means the bases are equal. That means the exponents are also equal. Okay, the next one is 4n equals 64. So you can write 64 as 4 times 4 is 16 and 16 times 4 is 64. So it would be 4 exponent n equals 4 exponent 3. You can see the bases are equal. That means the exponents are also equal, right? Okay, let's start with question number 7. Which do you think is greater? 5 exponent negative 2 or 10 exponent negative 2? Justify your decision. 5 exponent negative 2 or 10 exponent negative 2. So which is greater? Let's just see 1 over 5 square, 1 over 10 square, 1 over 25, 1 over 100. So 1 over 25 equals 0.04 and 1 over 100 equals 0.01. So which is greater? 5 exponent negative 2 is greater than 10 exponent negative 2, right? Why? When written in rational form, the numerator is equal to 1 and the denominator of both of these expressions is equal to base squared. So 5 is less than 10. So 5 square is less than 10 square. And so 5 exponent negative 2 is greater than 10 exponent negative 2. Got it? Okay, the next one is, which do you think is less? Negative 1 exponent negative 100 or negative 1 exponent negative 101? You have to see which one is less. The less one is negative 1 exponent negative 101, because you can see the other one is negative 100. 100 is an even number, so answer must be positive. Negative 101 is an odd number. That means the answer is negative. So that's why negative 1 exponent negative 100 is greater than negative 1 exponent 100 negative 101. Okay, we are done with the lesson. The rest of the questions you can do on your own. So if you need more help with the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. So we are done with the chapter 3. Okay, let's see. Okay, the next chapter is chapter 4, factoring algebraic expressions. So let's just start with chapter 4, that is factoring algebraic expressions. Okay, here is 4.1, that is common factors in polynomials. So let's just start with 4.1. Okay. Okay, factoring is the opposite of expanding, right? So factoring and expanding are opposite to each other. Expanding involves multiplying and factoring involves looking for values to multiply. One way to factor an algebraic expression is to look for the greatest common factor of the terms in the expression. So when you are factoring, that means you have to look for the greatest common factor. For example, 5x square plus 10x minus 15 can be factored as 5 times x square plus 2x minus 3. Since 5 is the greatest common factor of all the terms, it is possible to factor an algebraic expression by dividing by a common factor that is not the greatest common factor. This will result in another expression that still has a common factor. Like you can do step by step. You can divide like 8x plus 16. You took 4 common. You are left with 2x plus 2. Again, you can took another 2. You did this in 2 steps. You can either do in 1 step, right? So an algebraic expression is factored fully when only one or negative one remains as the factor of every term in the factorization. In the example above, 8x plus 16 is fully factored when it is written as 8 times x plus 2. Okay, let's just start with the practice questions. Okay, here it is. Identify the greatest common factors of the terms in each expression. Okay, question number 4a, 3x square minus 9x plus 12. Okay, 3x square minus 9x plus 12. Okay, you can see all the numbers 3, 9, and 12. They are the factors of 3. So you can take 3 as GCF and you are left with 3 times 1 is 3, 3 times 3 is 9, and 3 times 4 is 12. That is the factored form of 3x square minus 9x plus 12. Okay, let's just do another one. The D, 4x times x minus 1 plus 3 times x minus 1. You can see x minus 1 and x minus 1 as a common factor. You can take common. You are left with 3 plus 4x. Okay, let's just look at question number 5. Determine the missing factor. So you have 8xy, and on the other side you have 2xy. You have to find a missing number. So 2 times what number is 8? You have to make 8xy. So 2 times what number is 8? 2 times. That means 4 times 2 is 8. So the missing number is 4. Right? So the missing number is 4 because 4 times 2 makes 8. Here you have negative 49a square b5. You are left with just 7b cube. An easy way is like you are on the other side, you are given a square b5. You can divide it with the factor, one factor given. You can find the other factor easily. 7 times 7 is 49. Here you have b5 and b cube. You are left with negative 7. You don't have a square here. 5 minus 3 is 2. So it would be negative 7 times a square b square. So that means the missing factor is negative 7a square b square. Okay, the next one is 15x4z. Here you are just 5x square. 5 times 3 is 15. X square and x square makes x4 and z. So that means the missing factor is. Well, let's just start with question number 6. You have to find the missing factor again. 4x minus 4y, and on the other side you are given with just x minus 5y. That means the missing factor here is 4, right? Okay, then b is 8x minus 2y equals 2. You have 8x minus 2y. 2 is common, so you're left with 2 times 4 is 8 and 2 times 1 is 2, so it would be for here you have 2 times 4x minus y, so that means the missing one is 4x minus y. Okay, the next one is negative 24x square. We'll do it on board. Negative 24x square minus 6y. Okay, you can take common 6, negative 6. 6 times 4 is 24 and 6 times 1. So it would be 4x square plus y. That means 6 is the negative 6 is the common factor here. Okay, determine the greatest common factor of each expression. The question number 7 it is. 7x square plus 14x minus 21. 7x square plus 14x minus 21. Okay, so we can take common 7 because you can see all the numbers are the factor of 7. 7, 14 and 21. So you can take common 7. You are left with x square 7 times 2 is 14. 7 times 3 is 21. So it would be 7 times. Okay, the next one is 27y cube minus 9y 4. Okay, you can see 27 and 9, they both are the multiple of 9. So 9 is common. Here you have y exponent, here you have y exponent 4. Whenever you have the variables with powers involved, you can see the least power common. The least one is 3, so you can see y exponent 3 common. So you are left with 9 times 3 is 27, y cube is outside, and 9 times 1 is 9. Here you have 3y, here you have 4. That means you have one more y. So it would be 3 minus 1y. Okay, question number 9. Factor each polynomial, then identify two polynomials that have the same trinomial as one of their factors. Okay, A is DC square minus 2ACD. Okay, DC square minus 2ACD plus 3A square D. Okay, you can take D common. You are left with C square minus 2AC plus 3A square. Okay, let's just look at question number 10. Factor each expression ax minus ay plus bx minus by. ax minus ay plus bx minus by. Okay, so we can take common a from here. You are left with x minus y. Then we can take common b from here. You are left with x minus y. So that equals a plus b. The factors are as plus b and x minus y. Okay, the next one is 5my plus tm. 5ny plus tn. Okay, you can take common m from here. You are left with 5y plus t. So from here you can take common n and you are left with 5y plus t. So you can see 5y plus t, 5y plus t you can take as common factor and you are left with m plus n. So the factors are 5y plus t times m plus n. Okay, let's just do another one. 4mnt minus 16 mn minus t plus 4. So okay, from here you can take common 4 mn. So you are left with t minus 4. So you can take common minus 1 from here. So you are left with t minus 4. So t minus 4 is a common factor and we are left with 4mn minus 1. Okay. Okay, we'll continue from question 11 the next session. Let me just note it down. We have to start from 4.1 question 11 in the next session. For the next session, we have to start from question number 11, 4.1. Okay, so please make sure before the next session you can do till question number 10, 4.1, right? We'll start from question number 1 in the next session. Okay, so please make sure before the next session you can complete all the test questions for the lessons we did today. So if you need more help with any of the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. So if you have any question, you can please ask. I'm here to answer all your questions and confusions if you have any. No questions? Okay, that's all for today. See you in the next session. Bye, everyone.